Hello and welcome to Lesson 3, Special Factoring Patterns. Today we are going to continue to solve polynomials, but we're going to solve them using special factoring patterns that you already know, and then we're going to introduce a new one, sum or difference of cubes, and you can add that to your list. So let's review. When we're factoring, we always factor out the GCF, or greatest common factor. So we always look at that. And then when we factor that out, we look at what we have left, and in this case we have a quadratic, which then we can factor by grouping. And we know how to factor by grouping. We turn the quadratic into a polynomial with 4 terms, and then we group 2 and 2 together. We also learned about the difference of squares. If our first term and our second term are perfect squares, as in 25x squared and 49, and assuming it has to be a difference, we can take the square root of the first term and the square root of the second term, and we can do sum and difference to factor those. That's your difference of squares. This new special factoring pattern looks a little bit long, but if you pause the video and write this in your notes, all you have to do is follow these formulas and you'll be able to factor a sum or difference of cubes. So go ahead and pause and write this down. Okay, hopefully you've written it down. Now let's look at the sum or difference of cubes. And in both cases, you have to have a perfect cube for your A term and a perfect cube for your B term. So let's look at our example here. We have 8x cubed plus 1. We know we have a perfect cube if we can find a number that if it multiplies by itself 3 times, we get 8. Well, we know that 2 times 2 times 2 gives us 8. So 8 is a perfect cube. X squared is easy to see because x times x times x is x cubed. And then 1 is definitely a perfect cube. 1 times 1 times 1 is 1. 1 is also unique in that it's a perfect square. 1 times 1 is 1 for the squares. So 1 will always work. Okay, well, let's look at what we do. It's very similar to a difference of squares in that in a difference of squares we took the square root of the A term and the square root of the B term in order to get our sum and difference here. We're going to do the same thing here. So we have 8x cubed. So I'm going to write this down here. We have 8x cubed. So what we want to do to get our A term is to take not the square root, but the cubed root of that. The cubed root of 8x squared, well, the cubed root of 8 is 2, and the cubed root of x cubed is 3. So this gives us our A term. Now we need to find our B term. So we need to do the same thing. We need to take the cubed root of whatever we have in place of B. And in this case, it's 1. And we just said that the cubed root of 1 is 1. So now we know A and B, and we can just fill it into these equations. So in our first expression here, this binomial A plus B or A minus B, we go ahead and plug in the A, which is 2x, and we plug in the 1. And we don't need to worry about signs because these formulas already have the correct sign. So all you have to do is plug in the numbers. So notice we have 2x and then a 1 here, 2x plus 1. Then for our second expression, this trinomial, we take our A term and we square it. Well, if we take 2x and we square that term, you are squaring the 2 and you're squaring the x. 2 squared is 4. X squared is, well, x to the second power is obviously x squared. We can do the same thing with 1. 1 squared is still just 1. So for the A squared, that's 4x squared. And then it says a minus, so we put in our minus. And then we do A times B. Well, 2x is A, 1 is B. 2x times 1 is just 2x right here. And then we have our B squared, which I already found, which is just 1. So it's very simple in that all you have to do is plug in your A times B, your B squared, whatever it is, similar to the quadratic formula, in that all you do is find your initial A and B and you plug those terms in and you have your solution. So now this is factored. Where we would go from here is notice that we have a quadratic, 4x squared minus 2x plus 1. We would want to make sure that we couldn't factor that. If we can't factor that using grouping, then we would just leave it unless we were trying to solve, and then we could solve using the quadratic formula, or we could use completing the square if you like that method. Let's try some examples. where we actually do factor out the greatest common factor and we look at trinomials. So in this case, our first one, this is just a grouping method, but I wanted to show you this because it often gets overlooked and it's pretty common. So I have here three terms. I have a trinomial. Remember that when we're solving, we always set it equal to 0. So I would want to move the 4 over to the other side. And I'm left with now x to the 4th minus 3x squared minus 4. Now if you look at that, always check for GCFs. We have no GCFs. We definitely don't have a difference of squares because we have three terms, and we definitely don't have a difference or sum of cubes because we have three terms. So anytime you have three terms, we always want to consider factoring by grouping. So let's see if we can do that. So let's make our x. Now we already know that the coefficient of the x squared term, in this case it's x to the 4th. Notice that everything is doubled. Instead of squared we have 4th. Instead of to the 1 it's to the 2nd. And then we have our constant term. That's okay. The only place that's going to make a difference is at the very end when we write our factors. So let's go ahead and try to factor by grouping. So we have negative 4 in the top, and in the bottom we would have negative 3. So what times what is negative 4? That adds to be negative 3. How about negative 4 and 1? So that works. Now we're just going to go ahead and split this middle term, and we're going to factor by grouping just like we normally would. So now we're going to have negative 4x squared though, because this is squared, not x, and then plus 1x squared minus 4. So remember, I'm splitting this middle term. I'm splitting the x squared. Negative 4x squared plus 1x squared is still negative 3x squared. Now I'm ready to factor by grouping. So I've got my first group and I've got my second group. I'm going to factor out of this first term. It looks like I can factor out x squared because I have 4 x's here and 2 here. So I factor out an x squared. If I take 2 x's out of x to the 4th, I get x squared minus 4. Out of this first term, there's nothing to factor out. So if there's nothing to factor out, then I factor out just a positive 1 because I have to have something here when I'm grouping. And I'm left with x squared minus 4. Notice that if I take the 1 and distribute it into the parentheses, I still just have these two terms, these same terms. Okay, now I have these two groups, and I notice that I have the x squared minus 4 twice. So what I'm going to do is factor out the x squared minus 4 and then write what's left, x squared plus 1. Once I have this factored, then I can solve it. But notice something. I always need to look at my final factors to see if in fact it truly is factored all the way down. Well, x squared plus 1 is not a difference, so it's not a difference of squares. But notice this x squared minus 4 here. There's a difference in there. So I can use my sum and difference, which would give me x minus 2, x plus 2, to factor that. And then I still have my x squared plus 1. The key here is keeping track of all your x's. I started with 4. I should still have 4 in my final factored form. And I've got 2 here, 1 here, 1 here. So I do have 4. And that's especially important to keep track of when you factor out a GCF. Now I think I'm ready to solve because none of these can be factored anymore. Remember that when we solve, we just take each of the expressions and set them equal to 0. X minus 2 equals 0, x plus 2 equals 0, and then we have x squared plus 1 equals 0. On this first one, all we would do is add 2 to both sides, and we would get a final answer of x equals 2. So there's one of my x-intercepts, one of my solutions. In this one, we would subtract 2. So then we would get x equals negative 2. And there's another one of my solutions. These are both real solutions, remember. Now let's look at this final example here. I'm going to subtract 1, move it to the other side, but notice this is x squared. So now I have x squared equals negative 1. Well, in order to solve for x, I have to take the square root of x squared, which means I need to take the square root of negative 1. The square root of x squared is x, but what is the square root of negative 1? Well, you learned last lesson that the square root of a negative is I plus or minus I, and then what's the square root of 1? That's just 1, so we can leave it off. Plus or minus I times 1 is just plus or minus I. So we have these two solutions, which are imaginary, and then we have a solution here of 2 and a solution here of negative 2. So we have a combination of real and imaginary solutions. All right, let's try another example. X cubed equals 1. So right away I have two terms and I should be thinking to myself, ooh, a cubed. I probably have a sum or difference of cubes. Well, I don't know until I set this equal to 0. So what I need to do is subtract 1 from each side, and I end up with x cubed minus 1 equals 0. So now I have a difference of cubes. Remember that in order to solve a difference of cubes, what I want to do is take the cubed root of each of these terms, so I'll put a little 3 up here, to get my a and b. So my a is going to be x, and my b is going to be 1. And I don't need to worry about the signs because I've already identified that we have a difference of cubes. So I just need to use the equation and then I'm done. All right, so the equation says if you have a difference of cubes that you do a minus b, so we have x minus 1, and hopefully you have this in your notes. And then we take a and we square it. So our a term is x, we square it. And then the formula says we have a plus here, and then we do a times b. Well, 1 times x is just x. And then we plus again, and then we use b squared, which is just going to be 1. 1 squared is just 1. And this is our quadratic. Here's our binomial. And then we should be done. Let's see if we can factor this anymore, just to make sure. So in the top I would have 1. 1 times 1 is just 1, and in the middle term I have 1. Well, what times what is 1? That adds to be 1, and that's nothing. So I cannot factor by grouping. So I am done factoring, but now I need to solve. So in order to solve this quadratic, I would need to use the quadratic formula. Okay, so I went ahead and put all the numbers in the quadratic formula so you could see we have a negative b, and if we identify our a, b, and c for the quadratic formula, a is the coefficient of x squared, which is 1, b is the coefficient of x, which is also 1, and c is your constant term, which is 1 again. So they're all 1s. So we have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And now what I'm going to do is simplify this. Okay, so what I did is I took negative 4 times 1, which is negative 4, and negative 4 times 1, which is negative 4, and I got 1 minus 4, which is negative 3 over here. My final step then, because I can't take the square root of 3, so I can just leave that as a radical in order to have an exact answer. The decimal is not an exact answer, but I can take this negative out. And if you remember, when you take the negative out, it comes out as I. So we have negative 1 plus or minus, and then I'm going to have my I, square root of 3 all over 2. This is two answers. What are we forgetting? We're forgetting the x minus 1 here. So I've solved my quadratic, but now I need to solve the x minus 1. So don't forget about that. So we have these two answers, and then we have 1. Our 3, we should have 3, since this is a cubic. Our 3 x-intercepts are 1, and then these two imaginary x-intercepts. And now we have factored and we have solved. Let's try one more cubic example just to give you another practice problem to reference when you are doing your own. In this case, we again have to move over the 1, so we would need to add 1 to both sides to figure out what we have, but we can see that there's only 2 terms, so we probably have, and I see that one of the terms has a perfect cube, so I'm thinking we have the sum of cubes. Again, let's go ahead and take the cube root of both of our terms to figure out what our a values are. And we already know the cube root of 1 is just 3. The cube root of 8 is 2, and the cube root of x cubed is x. So there's our a, and there's our b. Now we can just plug it into the formula. Now this time though we have the sum of cubes, so it's a little bit different just with the signs. Our first binomial is just going to be a plus b, 2x plus 1. Our second binomial is our a squared. So remember in this case we have to take 2x and square it, and that's what will go here. 2 squared is 4, x squared is just x squared. Now in this case, if you look back at the formula, there's a minus here. And then it's a times b, 2x times 1 is just 2x. Then we have a plus, and then we have b squared, which is just 1. Again, we are left with a quadratic. We should always check to see if we can factor by grouping. So we would have 4 here. 4 times 1 is 4. We would have negative 2 here, and then we would ask ourselves, can we multiply two things to get 4 and add them to get negative 2? And the answer is no. We cannot do that. So we will have to use the quadratic formula to determine what our solutions are, our roots are. So again, I'm going to plug this into the quadratic formula, but let me go ahead and identify the a, b, and c. So our a is going to be 4, our b is negative 2, and our c is 1. Always remember to pull the signs. Okay, so now I have written out the quadratic formula, plugging these in. Some of you have had questions again about this negative b. We have a negative in our formula, but then b is also negative. So we write it like this, and two negatives make a positive. And then I've simplified. Negative 2 squared is 4. Negative 4 times 4 is negative 16, and negative 16 times 1 is still negative 16. So I get this. Then what we need to do is simplify a little bit more what's inside our radical. So we end up with 2 plus or minus the square root of negative 12 over 8. Well, when I'm looking at that 12, what I want to pull out are perfect squares. So what we have here is negative 12, and I know that the square root of negative 12, and I'm going to leave the negative out because I'm going to go ahead and pull that out. In fact, actually, let's go ahead and pull that out. So let's take this off. It'll be easier for us if we just take the negative out right away. So we know this is going to be 2 plus or minus I times the square root of 12 all over 8. Now we can simplify the 12. So the square root of 12 is really the square root of 4 times 3, or 2 squared times 3. The square root of 4, we know what that is. That's 2. We can't take the square root of 3, so that has to stay inside the radical. So now we can do our final simplification. We have 2 plus or minus 2i times the square root of 3 all over 8. Now this is a final answer, but it's best if we simplify this a little bit. We have 2, a 2, and an 8. Can I reduce that? So think of this as 2 over 8, and this is 2 over 8. I could reduce this. 2 goes into itself once, and it goes into 8 4 times. And we still have the plus or minus. 2 goes into itself once, so we still have the 8. And it goes into, or we still have the I should say, and it goes into 8 4 times. And then we have root 3. So this is a better reduced answer, but this answer up here is acceptable as well. Now remember, don't forget, we still have the 2x plus 1 up here that we need to solve as well. So we have 2x plus 1 equals 0. We move the 1 over and we get 2x equals negative 1. And then we would just need to divide by 2 to solve for x. So x is equal to negative 1/2. All right, our solutions are x equals negative 1/2. That's a real solution. And then our other two solutions are imaginary numbers. So again, we are Good, because we still have our 3 solutions and this is a cubic. Okay, and that concludes our lesson today on factoring. So hopefully now you are comfortable with sum or difference of cubes, and you've seen a couple of other examples just as a refresher.